So on this worksheet, we're looking at inverses. On the first problem, we're trying to write the domain and range of the original function. This function is a parabola that's shifted down 4 units. So normally we would have the whole parabola that we would graph, but this is telling us we're only going to graph it if x is greater than or equal to 0. So that's going to change things. If I plug in 0 in here, I get -4. If I plug in 1, I get -3. Plug in 2, I get 0. So all we have is this much of the function. We're not graphing the other side because we're not graphing it if x is less than 0. So based off of this, our domain then is from 0 to infinity. Our range, we look at our lowest point up to our highest point. So our range is going to be -4 to infinity. If I wanted to check my graph on the calculator, I could. This is a really nice thing to know how to do, is to graph only part of the function. So I go to y equals, I put in x squared minus 4. But I don't want it to graph the whole thing. So what I have to do, instead of using the semicolon, I have to push divided. Divided means I'm not going to graph the whole thing. I now put in parentheses that x, and I want to get greater than or equal to. The greater thans, less thans, all of those are under test. Test is right here under the green button, so I do second math to get to test. So I'm going to have it test the x values. If the x values are greater than or equal to 0, then it's going to graph the function. I'm now going to do a zoom 6, and here's the way the graph should look. So we're correct. We already wrote the domain and range, so now we're going to start finding the inverse. This f of x means y. The inverse of a function means that y becomes x and x becomes y. It makes the graph be a reflection over the line y equals x. So if I have this line here, y equals x, my inverse should be a reflection over that line. So here's my y, that becomes x. Here's my x, that becomes y. Solving for my new y now, I'm going to add 4. And now I'm going to have to take the square root. What do we have to put in front anytime we take the square root on an equation? Plus or minus. The square root of y squared is y. So I really have y equals plus or minus the square root of x plus 4. But watch if I graph this on the calculator. I'm graphing the square root of x plus 4, and I'm graphing negative the square root of x plus 4. That's what I'm saying the inverse is. So now when I graph it, here comes the positive and here comes the negative. Well, I'm only wanting the one that's the reflection over the line y equals x. I'll put that in there too. Which one's going to be the reflection over y equals x? Is it the red or the black? The red one, right? So I know this does not result in having an inverse. It's only the positive one that does. And now I can see that these are inverses. If I look at my table of values, I can see it as well. See how in my table of values I have the point 0, -4? On the inverse, I have the point -4, 0. If I have the point 1, -3, on the inverse I have the point -3, 1. All the x's and y's switch. So that means at the end, I'm going to say the inverse of the function is only the positive radical x plus 4. It's only going to be this part right there. That's what the inverse would look like. Here's another way that I know that. Because x becomes y and y becomes x, whatever the range is on this should be the domain of the inverse. Is the domain of this x greater than -4? Greater than or equal to -4? Yeah. The domain on this should be my new range. Is the range on this 0 to infinity? On my inverse, guys, is the range 0 to infinity? Yeah. So that's another way I know that this is the correct inverse. All right, let's look at number 2. How does this look? It's a shift which way? To the right 3. Looks like that. The domain then is from 3 to infinity. The range is from 0 to infinity. So I'm going to find the inverse. F of x means y. To find the inverse, y becomes x becomes y. To solve for the inverse, I have to square both sides, and I have to solve for y. This is what I get for the inverse. I don't want to call it y, though. I want to use the name of inverse, which is f to the -1 of x. But look at this. Here's my function. If I graph x squared plus 3, that's not going to be a reflection over the line y equals x. See, look. Here's my original. Here's what we're saying the inverse is. Here's the original. Here's the inverse, supposedly. Can you see how this is too much? That's not, all of that isn't the reflection. So what am I going to have to say to make it truly an inverse? Allison? Right. This is only the inverse if x is greater than or equal to 0. I can find that by looking at this range. Whatever this range is must be the domain for this new one. So if I took this and I said divide it up and only graph this if x is test greater than or equal to 0, now let's see if it looks right. Here's the original. Here's the inverse. Here's y equals x. Now it looks right, doesn't it? It's a reflection. So therefore, we know that is correct. All right. Just a hint. That is, if you have a cube, you're never going to have to worry about restrictions. The only time you have to worry about it is when you have square roots and squares. And that's because, think about a cubed function. If I have x to the third, look at that. Here's x to the third. Can you see how the reflection over y equals x, I wouldn't have to have any restrictions, would I? Because it would just go on forever. The domain and range is both negative infinity to infinity. But let's look at the back number 9. This is a very tough problem on here. Even on this problem, when we're finding the inverse, there's even more to do with it. So make sure you watch this one. F of x is y. To find the inverse, y becomes x becomes y. They're telling me that I'm only graphing this if x is less than or equal to 0. Let's look at it on the calculator to start with. So I'm graphing 3x squared minus 6, but divide it up and only graph it when x test is less than or equal to 0. And so here's what we're looking at now. And I'm trying to find the inverse. All right, so let's go with it now. Trying to solve this for y, my new y, I'm going to add 6. I'm going to divide by 3. So now I'm going to have this, y squared equals this. Just switching around the sides. Take the square root. And I'm going to split this up. This is radical x plus 6 over radical 3. We're not allowed to leave a radical in the denominator. So to get around the fact that I have a radical in the denominator, I'm going to multiply by radical 3 on top and bottom. Because these are both radicals, I'm going to have plus or minus the square root of 3 times x plus 6 all over 3. Now, thinking back to this though, look at this point right here. This point is 0, negative 6. So I know I'm going to have the point negative 6, 0. To be a reflection, am I going to want the top part or the bottom part? Or you can look at this. Here's the way that original function looked. Whatever the range is of this has to be the domain of this. And whatever the range is of this has to be the domain of this one. So what is the range on this function? Yeah. So we're going to have to look at the domain to find the up here we're saying x has to be less than or equal to 0. So am I going to want to use the positive or negative if my range here is going to have to be y is less than or equal to 0? How am I going to make that happen? Am I going to use the positive or the negative to make it so that my range is y is less than or equal to 0? I'm going to want to use just the negative, aren't I? And I'm going to call it this. I don't have to state anything else, but I'm going to double check and just make sure. So negative the square root of 3 parentheses x plus 6 out of there divided by 3. Okay, now we're going to check and make sure that this looks right. And that looks good. See the reflection right there? You should always see that point. It's not going to look perfect because we have a rectangular screen, but we can tell that that's going to be right. Okay, any questions over inverses? Domain becomes range, range becomes domain. So since the domain here was that x had to be less than or equal to 0, that's what our range had to be here, was that y had to be less than or equal to 0. And that's how we knew we had to use the negative.